Okay, so the last thing I need to show everybody is, there's two more examples I'd like to do. So sometimes they try to trick you with if they ask you to graph this function, 2x minus pi over 2. So we're used to it being in the form y equals a times sine of b times x minus c. So all we need to do on where the inside here is not in the form that we're used to is we just need to modify this with a little algebra. So we could write 2x minus pi over 2. Well, I could factor out a 2 out of both of them, so it's 2 times x. If I factor out a 2 out of negative pi over 2, it's minus pi over 4. And then you can continue to graph like we normally do, with a being equal to 3, b equal to 2, and c equal to pi over 4. Okay, so that's how you can, if it's not in this form, that's how you can use algebra to make it in the form that we like. Okay, the last thing I'd like to show you is, so we've talked about horizontal stretching and compressing, vertical stretching and compressing, and then also moving it, phase shifting from left to right. So now we need to learn how to move our sine and cosine graphs vertically up and down. So just like when we learned how to graph polynomials, exponentials, and logarithms, if you have y equals a times cosine or sine b times x minus c, and then if you add a value d, this d shifts is a vertical shift. Okay, so if I wanted to, for example, graph y equals cosine, so cosine of 2 times x plus pi over 2 plus 3. I identify a is equal to 1, b is equal to 2, c, so this is a plus pi over 2, so c is equal to negative pi over 2 because we want an x minus c, so this is really x minus negative pi over 2. Okay, and then d, our vertical shift, is 3. So if I have my graph here, well, I have to figure out the period. So the period of this graph is equal to, p is equal to 2 pi divided by b, which is equal to pi. And then my phase shift, so one cycle starts at negative pi over 2, and then I add my period to it. So that's equal to negative pi over 2 to positive pi over 2. Negative pi over 2 plus pi is positive pi over 2. Okay? And then if I take the period here and split it up into 4 spots, so I actually need to make this graph, I need to center this a little bit better. So this should probably be right here. So if I draw pi over 4, pi over 2, 3 pi over 2, negative pi over 4, negative pi over 2, negative 3 pi over 4. Should be a 4. And this is 0. So here, these are my 5, 3, 4, 5. Those are the 5 important points that we always need to map. So we started at the phase shift, negative pi over 2, and added a fourth of our period to get these 5 points. Okay, so this is a cosine graph. So the last thing you want to realize is now I need to add 3 to everything. So 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Okay. So this is a cosine graph, so we know the shape. But now since we're adding 3 to everything, we can draw our the way you can do this is if you want to draw like an imaginary axis here. So then at pi over 2, it's not going to start at 1, it's actually going to start at 4. Then at pi over 4, where it usually would come down to 0, instead of 0, it's going to be 3 because 0 plus 3 is 3. And And then it comes down at 0 to 2, back up to power 4, and then back up to 4. So this is what the cosine, and since it's a cosine graph, it takes this shape here. Okay, so you can add or subtract. So if I had a -3, it would shift it down. So we're gonna, now you can graph any trig function that takes this form, and you could also have a sign here. So remember, you need to, the process is always the same. Identify your values, figure out what your interval is, and then find those 5 important points, and take into account your vertical shift, and take into account which, if you have a sine or cosine function. Okay, so that's all I have. That's the last lecture. Thank you for being very flexible with this semester. And if you have any questions, please let me know. The final exam will be next Wednesday.